Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you to the next session of the Linux lecture series. And today we are going to talk about the geometry of hard disk. Right students, the permanent storage device inside our systems is called a hard disk or simply a disk. The two most common types of disk used in PC are the hard disk drive, which is normally called HDD. It is a traditional spinning hard drive having one or more metallic platters with magnetic coating that stores the data. The other one is solid state disk. This is a newer one and is replacing the traditional spinning disk. And on this SSD, the data is stored on interconnected flash memory chips. Let me write it for you. Interconnected flash memory chips. These flash memory chips are of different type than the one used in our USB thumb drives. They are more faster, they are more reliable, and of course, they are more expensive as well. Before we proceed, let us have a brief comparison of the attributes of these two types of hard disk. First of all, like no free lunch, the solid state disks are very costlier. A solid state disk of just 128 gigabyte costs you more than the cost of a 2 terabyte, the spinning hard disk. The speed, of course, the speed of SSD is too fast than that of the mechanical HDD. It runs application faster, it transfers files faster, and of course, it boots your system faster. There are no issues of fragmentation in SSD. If we talk about the durability, since there are no read or write heads flying over the rotating platters, so if you are rough on your equipment, SSD is recommended for you. As far as the size attribute is concerned, your sleek laptop devices like the one I'm using right now, my Mac Air, uses SSD because they are very slim as compared to their counterpart. And as far as the noise is concerned, even the quietest spinning disk emit a bit of noise when the platters spin at 7200 rounds per minute, while the SSDs make no noise at all, since they do not have any mechanical part inside them. So if price is not the issue for you, I strongly recommend you the solid state disk. Let's move ahead and talk about the geometry of a hard disk drive. In today's session, we will restrict our discussion on the spinning hard disk. Well, this is one of the snapshot of a spinning hard disk. You can see the disk platters over here. This is the disk platter. Let me take color, red color, okay. So this is the disk platter. Normally a hard disk contains more than one rigid disc-shaped platters, which are usually constructed of aluminium. A blank disk platter have a number of tiny particles very tiny particles, I can't draw that much tiny, having their own magnetic field, such that they cancel the effect of each other with the net result of no observable field polarity. This shaded portion is basically the head. You can see a head assembly over here, and along with this head assembly are attached arms, and with each arm you can see a head over here. Since in the diagram in front of us there are two platters, so if we want to read write both sides of the platters, we will be having four heads. This is the head 0. There will be a head 1 below it. This is head 2, and there will be a head 3 below it. So there are a total of 4 heads because there are two platters. A head is basically responsible for reading and writing data, or you can say that during a read or write operation, the head either reads or creates flux reversals on the medium to record the data. These all heads are connected to a single spindle or actuator whose movement is controlled by a stepper motor. So all the heads move together on the same corresponding track on platters. Let me talk about the tracks as well. There are concentric rings that exist on both sides of the platters. You can see this is a ring which we are calling a track. There are thousands of tracks on each side, and each track is of the same width as the head, so that the head can easily read a track. And on a track you can see a portion that is the sector. Over here you can see a cluster of 4 sectors. In between the tracks there are gaps, of course, which prevent errors due to misalignment of head or interference of the magnetic field. As these heads move to and fro, the track number changes. Let's suppose that this is track number 5. So if the head moves inward, the track number changes to 6, 7, and so on. Let me show you another diagram. Okay, this one is okay. So this is one track. The outer track, which I am shading right now. And this track has a lot of sectors on it, you can see. Normally there are 63 sectors on a track. After this track, there will be another track inside. And after this track, there will be another track inside, and so on and so forth. So if you have understood the track, what I mean to say is, as the heads move to and fro, the track changes. And this is what is known as the seek time. Seek time is the time taken by the read-write head to reach to a specific track. In today's mechanical disk, the seek time normally range from 5 milliseconds to 12 milliseconds. Actually, the smallest unit of allocation is the sector. A sector represents slices of the track and are the smallest unit of allocation. As the disk moves like this, the sector under the head change, and this is what is known as the rotational delay. For a disk rotating at 7200 RPMs, it takes about 8 milliseconds to have one complete rotation. So the average rotational delay is about 4 milliseconds, assuming that the data is halfway around the disk. So the transfer time includes the seek plus the rotational time. If you have understood the concept of the track and the sectors on the track and the read-write head, another important concept is what is known as cylinder. Right, gentlemen, the collection of all the corresponding tracks on all the surfaces makes a cylinder. Over here, if you see, this is the outermost track on this platter, and this is the outermost track on the other platter. And of course, we know that since both sides of this platter are written, so we have a track 0 on the upper side, we have a track 0 on the lower side, then we have a track 0 on this platter and another track 0 on the bottom side of this platter. So all these 4 tracks make up a cylinder. So if I say that this is the head 0, if this head 0 is at track 0, the head 1, head 2 and head 3 will always be at track 0 because they are attached with the same motor and these read-write head moves together. Let's suppose that this is track 20. So if head 0 is at track 20, all the other heads will also be at track 20. So the track 20 on all the disk platters makes up a cylinder. So once again, let me say that the collection of all the corresponding tracks on all the surfaces makes up a cylinder. So if I want to reach a particular sector, it will be having a 3D address of C, H and S. The cylinder, the head and the sector. The cylinder will decide on which track the heads should be moved, and then we will make either head 0 or head 1 or head 2 or head 3 active. Then the disk will rotate, and when the appropriate sector, this one, comes under the head, it will be red. So to uniquely identify a sector on a hard disk with multiple platters, we have a 3D address that represents the cylinder, head and the sector. Let's move ahead. Right, gentlemen, this is also a view of the actual view of a rotating hard disk. You can see the platters, you can see the motor in the middle which rotates all the platters together, and you can see this read-write head over here, and this is what the stepper motor moves, and this head either moves towards this side or towards that side, and the movement of the head of course changes the track, and the track on all the all the platters makes up a cylinder. So right now I want to talk about the interfaces. By interface I mean the pinouts of the connector, how you are going to connect your hard disk with your system. The interface with which a hard disk is connected with the motherboard or the south bridge of the motherboard have evolved over time. It has different attributes which are mentioned over here. We can have serial or parallel interface. These can have different data transfer rates. These can have different length, maximum length of the cable that they can support, the number of pinouts, the number of devices that can be attached with a single port, and whether they support hot plugging or not. Gentlemen, there are different types of interface. Let me mention a few important types of interfaces that are commonly used these days. The first type, that is ATA. It is also known as PATA. ATA stands for Advanced Technology Attachment. It has different versions: ATA, ATA2, IDE, EIDE. It is also known as IDE, Integrated Drive Electronic. Its data transfer rate is from 8 megabytes per second to 100 megabytes per second. It supports a cable length of 40 centimeter. The connector has normally 16 pins, and it supports maximum of 2 devices with a single port. And it is not hot pluggable. You need to reboot the system if you are attaching a new device with it. The other interface which has come up is Sata. This is Serially Advanced Technology Attachment. After the arrival of Sata, this ATA is also known as PATA. So in Sata, the data transfer rate is from 150 to 3 gigabits per second. The cable length is up to 1 meter. It has 7 pins and therefore lesser issues with electromagnetic interference. And of course it is hot pluggable as well. The third type of interface is the Scuzzy, Small Computer System Interface. It supports a data transfer rate from 4 megabytes to 320 megabytes per second. The cable length of 6 meter. Number of pinouts vary from connector to connector. We have connections from 8 pin to there are 68 pins as well. And it supports 15 devices with a single port. And of course it is hot pluggable. After Scuzzy, we also have the SAS, the serial Scuzzy, which is a bit interface to the Scuzzy, which supports data transfer of 3 gigabits per second and supports 128 devices to be connected with a single port. So after the ATA, SATA, Scuzzy, SAS, we have others as well, like the USB, Universal Serial Bus. You have the fiber channel. You have the Thunderbolt, each having its own pros and cons. So whenever you are going to buy a hard disk, a spinning hard disk, you must know what type of interface it offers you. Now, gentlemen, let's have a brief review again that how reading and writing of a CHS disk is carried out. In the very beginning, the operating system sends the block address, a linear address to the disk controller. It doesn't send a CHS address. It sends a block address. The disk controller converts this linear address called the logical block address to appropriate CHS address. So remember, OS sends a linear address and the disk controller converts it to appropriate cylinder, head and sector. And then the disk controller moves the motor attached to the head assembly so that the heads can be moved to the specific cylinder or track. After the heads have moved to the appropriate track, they switch on the specific head, whether the head number 0, head number 1, 2 or 3. The disk platters rotates and they rotates until the specific sector comes under the head. And when the specific sector or sectors come under the head, the data on that sector is read and placed in a disk buffer to be read by the operating system kernel later on. So students, this is how the hard disk is read. And the same is the procedure for the writing of the hard disk. Now let us quickly try to understand the difference between the logical block and the 3D CHS addresses. Right, gentlemen, the newer disk comes with the LBA settings. The older disks use CHS addressing to access sector on the disk, but these days our hard disks use LBA. Okay, so they have a support of previously 24 bits. In the 24 bits LBA, the 10 bits were for the cylinder, 8 bits for the head, and 6 bits for the sector, starting from sector 1. So keeping this configuration in mind, the maximum number of cylinders can be 1024 because it has 10 bits. The maximum number of heads can be 256 because there are 8 bits for the heads. And the number of sectors 63 because there are 6 bits for this. And each sector is of 512 bytes, so we multiply this with 512 bytes, and the maximum possible size of the hard disk that a 24-bit LBA support is 7.8 GB. We later moved on to 28-bit LBA with 16 bits for cylinder, 4 bits for head, and 8 bits for sector. Although 8 bits for sectors, but mostly the sectors were used from 1 to 63 only. So theoretically, the maximum disk space support for 28-bit LBA is 127.5 GB. These days, we have the disks that support 48-bit LBA, and they support a max hard disk size of 128 PB. Now let's see how these logical addresses are mapped onto 3D addresses. Right, gentlemen, this is a 3D address cylinder 0, head 0 and sector 1, which is mapped to LBA 0. And if you see over here, the cylinder and head, that doesn't change, and the sector keeps on changing up to the last sector, and that is 63, which maps to LBA 62. And after that, the head change from 0 to 1, the cylinder doesn't change, and this value is mapped to LBA 63. And this procedure continues. So let me say that every CHS value is mapped onto an LBA index. And LBA index starts from 0th cylinder, 0th head, and first sector, and it continues. Once the track is exhausted after 0063, the LBA numbering continues to the next head, that is 011. After this is exhausted, the LBA scheme moves on to the next head, and this procedure goes on and on and on. And in this scheme, the most important part to observe is the cylinder changes after a very long time. So it is very rare that there is a file which is located on two cylinders at the same time. So normally files either exist on the sectors, or maybe the head has to change to read the file. It is very rare that the cylinder has to be changed to read a particular file. So this scheme reduces the seek time of the hard disk. So one last thing. Let us try to understand that what formula is applied to carry out the conversion from CHS to LBA and vice versa. This is the formula that is in front of you, that is used to convert CHS to LBA. Let us take an example of 023, cylinder 0, head to sector 3. Let's see to what LBA value this is mapped to. And let's suppose that we are talking about a disk with 16 heads and 63 sectors per track. So putting on the values, C means the cylinder. We have the cylinder 0. TH means the total number of heads. We have 16. TS means the total number of sectors, which is 63. H means the head, which is 2. Total number of sectors, we have 63, plus the sector, which is 3 over here again, 3 minus 1. And this is calculated to be 0 plus 126 plus 2, and this is 128. So that means 023 CHS address maps to LBA 128. Let's check it on the previous screen. 022 maps to 127, and after 022 there must be 023, which will map to 128, of course. And this is what our answer is. Similarly, we can perform it in the reverse order. If we have been given the LBA 128, we can map it to CHS using these formulas. Cylinder is equal to LBA 128 divided by total number of heads, and the total number of heads 16 multiplied by total number of sectors, which is 63, and this maps to 128 divided by something quite big, maybe 1310008, and which is of course 0 because we consider the integer division. So 0 is the head, and of course we have the head 0. As far as 0 is a cylinder. Okay, this is a cylinder. Now we talk about the head. LBA 128 divided by total number of sectors 63 mod 16, and 128 divided by 63 is almost 2, and 2 mod 16, and which is again 2 of course, and the head is of course 2. And finally the sector LBA is 128 mod total number of sectors is 63 plus 1, and this is 128 mod 63 is again 2 plus 1 is equal to 3. So gentlemen, these formulas, you can use these formulas to convert from CHS to LBA and from LBA to CHS. So let me sum up. Today we have talked about the types of the hard disk. That there are two main types, the spinning hard disk and the solid state disk. We have made a comparison of the price, capacity, speed, fragmentation, durability. We have talked about the geometry of the hard disk, cylinders, heads, sectors. We have talked about the interfaces of hard disk, and finally we have talked about the LBA addresses and their mapping from CHS to LBA and vice versa. Hope it was informative, and inshallah ta'ala we will meet next time with some new topic, maybe related to the disk. I wish you all the best. Allah Hafiz. Happy learning. तुम ही से ऐ मुजाहिदो जहां